Indians can do hard things, right? You don't really have to move to California to change the world.
Seeing the launch live, it's so exhilarating. And because a lot of the team is not from a space background, this was their first time, and that's just a different feeling.
मतलब आंसू आ गए थे यार. It was like that.
There are only two other countries really that have private launch capabilities that are from a private company. You have the US and you have China. You haven't had a single European private company launch a rocket to orbit yet.
Many countries are now starting to look inwards to develop sovereign capabilities because I think the writing on the wall is no one's coming to save you.
What about the global south? Countries who also need satellites as a part of their own defense, right? They don't have the NROs, they don't have 6-decade-old space agencies. Who's going to serve them?
No one's going to let you have the best of anything. So the US will never let you have F-35A. You can have B and C. You'll never get the top variant. And if you hope to have those capabilities, you have no option but to build them, develop them in-house.
Fools study tactics, geniuses study logistics.
Yeah.
It's the supply chain that gets built out, it's the ability to replenish that gets built out that allows nations to prevail in many ways.
Need to be open to failures, that this is space, it's hard. There will be failures, but it's more about the resilience.
If you risk nothing, then you risk everything. I think that's true more than most for space technology.
There'll possibly be 10 companies that will come out of people who worked at Skyroot now, because they now believe that they can do it and they've pulled it off. And they will just have problem statements for Skyroot that they'll need to solve, each one of which could potentially become a new company 10 years from now.
The fact that we are even imagining a future like this is crazy.
All right, listeners, this is our fourth roundtable. This is a new experiment that we've been trying. It's different from our routine IP, which is the live streaming that we do. And this one is focused in space. We have a very, very exciting panel of 4 guests, 3 of whom have actually been on the show before. We love having them back. And then there's Rahul, who's actually coming to the offline network for the first time. Guys, first of all, welcome to the show. It's great to see all of you.
Thanks, bro.
Likewise.
I love the fact that everyone in space just knows each other. So I think we'll just maybe get started by getting your initial reactions to the Skyroot launch. For the 3 of you who've been on the show before, maybe you could just quickly reintroduce your company, tell us what's been up since you came here last, and then Rahul, we'll of course get you to spend some time talking about what you're doing at Industrial 47.
Sure. Should I go first?
Yeah, Shreyaans, let's roll.
Welcome back, guys. I'm Shreyaans, and I'm the CEO and founder of QOSMIC. And the goal of QOSMIC is to build the optical highway to the cosmos, essentially the full stack solution for optical connectivity to and fro from space. And talking specifically, we can do the whole Skyroot bit later, right?
Yeah, any order, really.
Okay.
Let's just chat about what's been happening at QOSMIC since you last appeared on the show.
Given that I was just here 2 to 3 weeks ago, we've still been able to make a decent bit of progress. We have gotten our transmitter and receiver all together now. So we are just going out to the field. Yeah.
Phenomenal. What do you make of the Skyroot launch?
Oh, I absolutely loved it. I took the team down to Shar that very day, and just seeing the launch live, it's so exhilarating. And because a lot of the team is not from a space background, this was their first time, and that's just a different feeling.
Fantastic. Awais, what are your thoughts on the Skyroot launch?
Yeah, I think 2 probably slightly contrasting feelings. I think number 1, spectacular. To be able to see it take off so smoothly, take off so rapidly, honestly, with a solid motor, and it was just like off the pad in just a few seconds, and then being able to see the deployment and those sunrise views. I think, firstly, very spectacular. The second was relief that we have yet one more launch option now, thankfully, out there in the world to launch our satellites. SpaceX has been getting increasingly crowded. ISRO has been running a backlog of many launches, and so we desperately needed more rockets to send our satellites up there in the coming years, and glad that we have a space to an option now. So I think it was exhilaration and relief.
Wonderful contrast, yes. Gaurav?
Yes. Yeah, it was lovely. Any launch always is very, very exciting. And, this particular one, I think it signifies a lot of things. Indians can do hard things, right? You don't really have to move to California to change the world. So, deep tech, which was always thought of as a very long game. I think this has given the first signs of outcome. So I think very, very positive for the whole sector.
And Rahul, that leaves us with you. Your thoughts on Skyroot, and we'd love to know more
Not
about
not
your
much
work.
left to be said, right? But no, it was fucking amazing, man. That's about the
That's
only
what it
thing to
was.
say. It was viscerally joyous. That's I was strangely in a cab during that period of time when I saw it, and I think like I whooped. That's the simple answer in many ways. It was amazing to just see ye ho gaya. And then all the platitudes, etc. Definitely like 28 years old, average age, all of that, incredible. But just like what the journey of the last 8 years, 9 years, what they've pulled off, and seeing it come to fruition, thoda to matlab aansu aa gaye the yaar. It was like
Yes.
that. Uh, it felt amazing.
Yeah.
Can everyone guess
I'll
that
leave the
Rahul?
commentary outside of that.
Can
And
everyone
tell
guess
us
that
more
Rahul
about your
was in
work
the
as
debate
well.
club?
Sorry?
I was like, can everyone guess that Rahul was in the debate club with all those fancy words?
I like big words and I cannot lie. Um, but yes, work. Well, I run an early stage venture firm. We're called Industrial 47. We do primarily what I call sovereignty and issues of national importance. These are the areas that we invest in. Space is where my journey started. Incredible to see the three gentlemen in front of me. We met at different points of time in life across different things. So, from the fund, we've invested across marine autonomy, a company that's building autonomous submarines. We invest in a company that's building counter drone systems for the government and for a lot of other folks. We've invested in a company that's still stealth, so won't talk about that. And we invested in India's first nuclear fusion company as well. So exciting updates coming from all of them very, very soon. So it's been an
यार हम
exciting
सबको
period
तो
to do
भूल
the
ही गए.
work.
हम
You
तीनों
guys are
कहाँ
the
हो?
reasons I can do what I do today in so many ways.
So tell us the story. How do all of you know each other? Because I know all of you know each other. Your paths have crossed at some point or the other. So any one of you, just tell that story. And I will
I will take the liberty to do this.
please
So
do.
all of Indian space is basically one WhatsApp group. Uh,
What's it called?
everybody, new space.
Very active group. Yeah.
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 I would say one of the very few groups I've yet to mute in many ways. But yeah, so I met Awais. What November 2018 is when we met and talked, and there's a full story around that. That was a crazy ride. Gaurav, I met. This was June 23, June,
Correct.
July 23. The Venus mission had been pushed off, and that's when we talked. That's when the company was called something else entirely.
Yeah.
That's what the group for a while was called as well. And Shreyaans I met because I decided after having invested in enough space companies that I should educate myself about this area. And I took a course at IISc. It's a 6-month advanced program that they do. And for their demo day during that, at the end of the program for a week, you come down to campus, you come see a lot of other companies there, meet professors there. And that's where I met Shreyaans working in Professor Alok's, with Professor Alok in his lab,
Yeah.
where he wanted to build about 4 space companies simultaneously. I think that was the plan where it started from. So that's how I know all three of them.
He's at least gotten started on one. The other three will follow. And Rahul, I think our listeners will also find it very interesting to know that you're a serving infantry officer in the Assam, one of the Assam Regiment's reserve battalions. So tell us more about that. Is that something you like
Uh,
talking about?
इस पे तो
Not that I
Reddit
have an
आंसर
option
मिलता
now.
है पूरा.
Now we put you in.
We'll have to do a full AMA. But yes, so I serve with the Indian Army Reserves. They're called the Territorial Army. I was commissioned into the Assam Regiment. This was about 10 years ago. I now serve as a major. I've done the way it works in India is you've got to do 2 months of military service every year. And that service is generally in an area where your battalion is deployed. So for me, it's been the Northeast, from North Assam to South Assam, Manipur, Meghalaya, and those are a bunch of the areas I did. I spent about a year with my battalion, I would say about 6, 7 years ago, serving full time, sort of my own personal tour of duty in some ways. But now I do 2 months a year.
Yeah.
That's the TLDR.
Thanks for sharing. All right, now we're just going to bring the discussion back to Skyroot. And here's the thing: there's four of you. If for some reason I want one of you to respond to something, I'll call you out by name. All the other questions are frankly directed to everyone. So really, whoever wants to go first, and the others can follow. So I think Skyroot demonstrated launch capability. Now there are reports that Agnikul will soon be experimenting with reusability, which basically means a few years from now we'll likely have an indigenous launch industry of our own. I'd love for you to help us understand how that will change launch economics going forward for Indian space companies.
I mean,
Okay,
happy to
I'll go
take it.
first. Okay, go for it. Go for it.
Okay.
After.
Probably a slight bit of delay there. So I think it's firstly, let's look at the Skyroot launch with regards to the context, right? So there are only two other countries really that have private launch capabilities that are um, from a private company. You have the US and you have China. You haven't had a single European private company launch a rocket to orbit yet. You haven't had any other geography do it. And so I think being only the third, with companies starting much later than some of these other geographies, especially also uh, leapfrogging Europe, where you have had Ariane and where you had, if you consider Russia part of Europe, erstwhile Roscosmos and things like that, I think firstly, not many countries have that capability. And I think that speaks to India's own national capabilities and ambition. And there are two aspects to it. I think number one is local capacity. India itself wants to launch many hundreds, probably thousands, at some point, maybe 10 thousands of satellites. And if you have to do that, you have to have your own launch capability, right? You can't be dependent on some other country's launch to send those up. And this is, predominantly capabilities for the armed forces, its capabilities for the space agency here, etc. Of course, we've had the PSLV and the SSLV and the GSLVs from ISRO, but then those are also being gradually given out to the private sector through technology transfers. But having something that was designed completely from ground, I think that was important. And second, as you said, is the international market, where you have to now start bringing in business for satellites being launched from other countries to here in India. It used to be the case with ISRO when it was the cheapest, and then SpaceX came in with the reusability and sort of changed that game. But I think start with, you don't even need to be cheapest. You don't even need to have the economics worked out. You can probably charge a premium, and still there's, as I said, there's like a backlog with SpaceX of many months. There's a backlog with ISRO, and so having just one more launch option just means you can sort of go and book there. In the long term, I think with reusability being plans for both Agnikul and Skyroot, the costs will start to come down again, etc. But I think that's roughly the situation from my point of view.
Awesome. Yeah. So one thing to understand about the launch industry is that it's very similar and analogous to normal transportation industry. Just like, to go from point A to B, you can take a metro. So think of SpaceX rocket as a metro, which drops you at, a specific large point. But then you also need a chauffeur-driven car, which drops you right outside your house sometimes, right? A specific orbit, which you can get from like a Vikram rocket from Skyroot. And why do you need the latter? I'll give you a use case. For example, PierSight has to build a maritime satellite for Singapore, where they want each orbit to cover the port of Singapore. So they'd like us to put in a specific orbit such that Singapore turns up, the most often. So at those points, you can go for a smaller dedicated launch vehicle. But the economics is more in the favor of the former, because of course they have reusability. And right now, for an apple to apple comparison, uh, assume I send a 300 kilogram SAR satellite on a Skyroot rocket versus a SpaceX rocket. It'll cost me about 2.1 million on a SpaceX rocket, while a Skyroot I need to build, buy the full rocket out. So of course it'll be over 5 million for sure. But that's where an interesting turn comes in. The Indian government recently announced a 30% subsidy on someone building a satellite in India if you launch from an Indian rocket. And Gujarat government on top of that gives a 25% more subsidy. So that 6 million thing with a 55% discount now actually starts making sense. And once they have enough business, they can get into reusability, and we can get into a situation where Awais was talking about. So that's my take on the situation.
Yeah, and I think both of them have reflected the point that drives me the most, which is how does the economics sort of pan out? Because we are seeing this with SpaceX and their launches being booked out. People have to rework what their unit economics are looking like for each one of these satellites. And when speed becomes a premium over availability, then it's interesting to see how the in-space economics pan out with constellations being planned, because these dedicated launches will essentially enable significant amount of satellites being launched repeatedly, even if you're paying a premium. And that just shows you that at scale, are you able to amortize your cost back? Like, is your EO data or any other data that you're getting from space, even at that premium that you're paying for speed with Skyroot, are you able to bring that back down to the ground? Yeah.
I think the if we it, I'm more excited about like the second order effects of how more launches being available will ensure what speed we build satellites at. For example, today this launch cadence dictates the speed at which we build things, the speed at which, in many ways, supply chains get built out to be able to do this. So I think the taking the road analogy there, you have actual highways, you have information highways, which is broadband,
Yeah.
and now this is a highway to space. And when you have more of that, you will produce more things to be used on that highway, and that then builds out a different kind of a supply chain that exists. It says, okay, because there's no constraint, right? Today, you're like, hey, my launch is a year and a half away. So if I'm starting to work today, this is how I'm going to be working. Versus saying, okay, I have 6 months to be able to, I have the actual ability to launch in 6 months. How do I make this faster? What are things that can happen over a period of time that are possibly quicker? Which generally is capacity expansion in many ways. So it's that highway analogy. Highway banega, fir dhaabe banenge, then more people will eat, more people will travel. All of these things will happen. And I think that that's what we'll see blossoming out in many ways.
Yeah.
Yeah.
Use cases that just didn't make sense earlier in many ways. Like the whole SpaceX with the Starlink constellation being a combined economic package being something that makes significant amount of sense,
Yeah.
not as standalone in many ways.
And it almost feels like ISRO is now leaving at least the low Earth orbit to you guys, right? They're like, okay, this is your domain now. We're moving a little more upstream. So I'd love your thoughts on, what are the priorities for the National Space Program right now, and with private players like yourself in LEO, what are some existing opportunities that you guys are already going after, and what still remains some untapped opportunities?
Same order.
Okay, happy to go first. I think I don't think it's like strictly Leo Mio Geo. I think what's
Yeah.
happening is there is starting to become a divergence between cutting edge research and development versus commercialization, in a sense. Not to say that there isn't R&D on the commercial side, quite a bit of it, but like what is considered like science, and what is considered like engineering, in a sense. So let's look at ISRO, right? I think the focus predominantly has been on planetary missions and on human space flight, with Gaganyaan being a major component of the budget itself and also what the plans are. We had astronaut, Shubhanshu Shukla go up to space, but that was on a SpaceX rocket with sort of Axiom and things like that. But we are going to launch our own men and women from Indian soil, hopefully to an Indian space station built of our own, and then be able to go to the moon, Mars. Obviously, there's Chandrayaan 3 that happened, Chandrayaan 4 and 5 will sort of come there. There's right? So that's something that doesn't make sense for a commercial entity. There's no money
No
at the
way.
end of it, right? And so that's science and that national pride, and ISRO will continue to do that, which means everything else, which is in a sense commercial, where ISRO was doing launches where they were getting paid to launch satellites up to orbit, or building and operating a fleet of satellites, whether that is imaging satellites, whether it's EO or SAR, whether it's communication satellites, whether it's weather satellites. I think all that will start to be opened up to the private sector, and that's like in the near term. In the very long term, I think the cutting edge nature of things also should hopefully get opened up as well, similar to how you see in the US with the CLIPS, the commercial lunar program that you have, where NASA will give a contract to someone like an iSpace or Firefly and others to build lunar landers and stuff like that, which means that now you have good partnerships in the long run for expanding and exploring the solar system as well. So I think that's a brief on I think the opportunities now are take everything that was commercial that ISRO was doing or not doing, and building local private capability, and in the long run contribute to these cutting edge science missions also.
Wes, don't you have a long-term cutting-edge plan to go mine asteroids?
Hopefully not too long term, maybe a midterm plan. But yes, I think the initial idea for hyperspectral came because hyperspectral is going to be a key component to monitoring what asteroids have what, and so it was always, I think, in my mind at least, reading science fiction, the ultimate use case on saying, if we can mine asteroids and build stuff in space, I think that's the way to go. So hopefully one day we can partner with this route to sort of go get an asteroid or extract something from there. Yes.
Yeah. No, I think we covered it very comprehensively, but I'd like to give a different take on it. There are some private companies you see in France and US which have come out as offshoots of the National Space Program. Like if you see CLS, MDA. So that kind of a thing interests me a lot. That why can't a private and government company be in partnership in equity or have a spin out of ISRO and slowly start divesting it till it becomes fully commercial. So I think that is something we haven't seen a lot here, but there have been some very recent successes in, as I said, France and Canada with CLS and MDA. So I think seeing something like that will be very, very interesting.
Yeah, absolutely. I think the one change that we have actively seen in the way the defense and the Indian, how do I say this, research community or just ISRO in general approach this new area and this new space age is that they're trusting folks like Awais, folks like us to be able to build for this economy. And that's absolutely the right call. We saw this in the United States where they actively worked with private companies as the space missions in the past 60 years were being planned, and this is how you do nation building. Like for the Indian defense, the goal is not to make money out of this, it's to have capabilities, and having a private launch option, having own ISRO allows them to dip their hands into newer areas, try out newer ways of communicating, newer ways of designing constellations, because again constellations are not just a one method way of designing things. You have a constellation coming up with PierSight and Pixxel. You have different kinds of comm satellites which can form constellations, and that is the kind of capability that these guys can now walk into without having the overhead of do I need to make money, and try out different things that we can do in space.
I think more than a specific orbit or ISRO saying, okay, do this, the private industry in space has existed in India. Key examples being, say, Anant or Centum or places like these. I think the main difference we've seen over the last 8 years, if you want to think about it, or 7 8 6 7 years as such, is ISRO saying that everybody prior to that was a subcontractor to them, somebody that they gave things to and said build it out. Sometimes on an R&D basis, sometimes on a cost plus basis, sometimes on like technology that they built, handed over and said just operate this for us. So there were multiple examples of those. I think the key changes for the first time they're saying you can be a prime integrator yourself. You can be somebody who puts together the whole system, operates it, runs it, and does it. And I think that's been the key change. Like whether it's Geo or Leo, it's just I think Leo is primarily a function of the capital availability in private markets today.
Yeah.
It's not a function of okay, they've said okay, you do Leo, we'll do Geo in some ways. It's just that
Yeah.
I don't think a single company in the country so far has raised enough money to build a full-fledged Geo satellite. So it's a capital structure thing that's led us here, which also makes obvious amount of sense in many ways. But the key difference is this: you can now build system integrators, which you
Yeah.
couldn't earlier.
And maybe the fact that certain commercial applications are best conducted in low Earth orbits. So there is that angle as well. I want to maybe get quick reactions from you guys on the Indian space policy of 2023 as well, and the enablement that it has led to. Since it's been rolled out.
It pushed me to start a company. I
Yeah.
mean, I was still building satellites, but I mean, I did have the guts like Awais and others before the policy. Once the policy was out there, it made all the sense that, hey, I'm at the right place at the right time. I know how to do this. Done this for a decade. Let's jump in now. So for me, it played a major role.
In fact, a related question to this for you, Gaurav, would be
Yeah.
if there's someone today who wants a lifelong career in space, and they're thinking, hey, should I join one of these guys or should I go work for ISRO? How would you help them navigate that dilemma?
So, like, if you want to do pure science and you want to work on a Venus mission, right now private companies can't offer you that. But yes, if you still want to work on the same tech, a more agile methodology, to be honest, uh, you can come to a private company. Like when I started back in 2014, ISRO was the only place, right? And I used to think that, this is my dream job, but where does everyone else go? These guys just recruit 100 people a year, and this is a big country. But now there are many options, and I love that. Yeah.
Yeah, as the only one who's not building a company here, I would say it's not an either or. Just like there's a shortage of talent in this entire space, so go work anywhere.
Yeah. I think. What do you want to add something to that, Awais, Shreyaans?
I think it pushed Gaurav to start a company. I think it made all our illegal companies legal. That now we are allowed to work in a sector that is allowed for private sector. Earlier, it
Yeah.
was restricted to ISRO. No, but I think it's genuinely been, I think, a very rare case of the government being a true enabler. You don't see that in a lot of countries. I think US has always been quite different, but it also took decades for it to evolve to where it is, with the processes and the approvals being straightforward. But with India, we managed to do it in less than 2 years, right? From when it was announced that private companies can now go do space. Sadly, we were in that 2 years also where it was a little bit chaotic, where we were the first company applying for a bunch of stuff, and so we had to figure out through various ministries how that worked. But then, by the time in space was set up, and then the space policy came out a couple of years ago, in fact, I think the Indian regulatory regime is a lot simpler in some ways compared to some other countries you will see elsewhere. There's just a single window, and there is a genuine incentive and alignment to actually help move things along. The solution mindset is, can we help solve this, rather than saying, yeah, the law doesn't allow it. For example, I'll take an example, right? When we were looking at launching with ISRO, we had to end up paying, an 18% GST compared to launching with SpaceX, where there was no GST. And so we are like, hey, look, we're being penalized to launch Indian-made satellite in India versus launching it in US. And a couple of months later, the GST was completely revoked. It was taken up at the Space Commission level and sort of done that. Right, when we needed to test our satellite at an ISRO facility because we didn't have the testing facility, there was no process in place at that time to sort of do that. But the government was like, you know what, let's figure it out. Let's figure out what kind of a agreement needs to be there. All that is now has been actually standardized as well. So it not just benefits Pixel, who knows how to do that. It benefits even a company started 2 months ago who have hardware and want to go test it out or launch something or build something. So I think in that way, it's really been a big enabler from a space policy
But I
standpoint.
think what we're also picking up on is, even before there was a formal policy in place, there was still someone you could go talk to and talk to about your challenges, and someone was always listening and helping figure out solutions. So that's also heartening to know. Um, all right, and a part of that policy is, of course, like some super creative public-private partnership frameworks. One such example is the National Earth Observation Constellation that Gaurav, Awais, you guys are working on. So tell us more about that and any recent progress or updates you'd like to share from that effort.
You want to start, Gaurav?
Yeah, sure. So I think we were talking about authorizing and empowering. This one is more on the promotion side. That okay, now we've made people start companies. Uh, where do they get the demand from? And firstly, let's tap on the national demand. Uh, Through a survey, they figured out that India is procuring about 1,400 crores worth of data from foreign providers, and all of this non-defense. So why not build a national constellation as a part of the PPP framework, and stop that import of data happening, and that also kickstarts or gives a push to your local satellite companies such as PierSight and Pixxel. So great idea. And in terms of progress, the company has been formed. We've started the work on the designs, are at the design reviews, and I think end of next year we should have first launch. Awais, over to you. Yeah.
Yeah, no, I think it's one of those things that was slightly creative, where in space figured out, let's see what can be done within the bounds of what is possible. So we didn't really copy what Europe was doing or US was doing, right? So in the US you have Landsat, which is uh, operated by NASA, but then subcontracted to just one company, and then you have Sentinel in Europe, which is also built by private companies, but then owned by ESA. In India, the idea was, okay, if you really want to promote, as Gaurav said, promote the private sector, let the private sector come up and own assets. So there's obviously skin in the game. We're putting up a large chunk of the investment. The risk is ours. We have to make sure that the satellites do go up there and work. But in return for that, there's so much demand for the country. It's a huge country. It's a subcontinent. It's called a subcontinent for a reason. And for that amount of land, whether it's for agriculture, whether it's for coastal monitoring, whether it's for disaster monitoring. I think you only really have satellites that can do all of that, and bringing together multiple startups, not just like one large established company who's already making a lot of money with defense contracts, but actually giving it to startups who are going to go and build it. And they were doing some parts of it anyway, but then you bring them all together, you tie it with the needs of the government of India or the country of India, and I think there's magic to be made there. So I think let's see how that works out, but it's a unique setup compared to most other countries, and it's truly a public private partnership in that sense. So being able to work with folks like PierSight and Dhruva and SatSure means that it's not just one company benefiting. You now have multiple folks benefiting, but multiple folks also building capability and capacity inside to be able to go there.
I believe there's 4 of you in that consortium,
Correct.
and all of you do
Correct.
different kinds of sensing and imaging.
Correct.
Okay, fantastic. But my next question is for Shreyaans. So Shreyaans, once constellations like these come online, and there's going to be many more of many more of them, the need for those information highways only goes up. So help our listeners understand the growing importance of inter-satellite comms and then satellite to ground comms. And the thing is, every time we hear space, your mind suddenly goes into deep space. You forget that there's extensive ground infrastructure that's also needed. So talk to us
Exactly.
a little bit about that too.
So we can launch n number of constellations in the sky and do a lot of compute in space, but we still believe a lot of this data has to come back to the ground. All of this data has to come back to the ground, because at the end the operator has to drive analytics on top of this. So we can have very good hyperspectral, very good SAR satellites, but at the end the operator on the ground has to know, what do I do with this? And that is exactly where we see a decent amount of data backlog. And we believe that all of these satellites should run at maximum efficiency. So we've seen how satellites get designed, how constellations get designed, and a lot of this is essentially driven by, hey, this is the X-band or S-band antenna that I have on my satellite, and this is how I'm going to design my mission parameters. With optical, that sort of goes out of the window, because now you're able to do as much throughput as you want. And so you're able to run your satellites at the peak efficiency as you want to run it at. And that is where, more than throughput, I believe the fact that it is spectrum less helps you significantly more than anything else. So you're able to not have to deal with ITU filings and a lot of this other weight that you need, and just communicate like Wi-Fi calling. And that is where inter-satellite links play a decent role in these constellations. Now I know that at least for this constellation, inter-satellite links are not in picture. But how do you guys view inter-satellite links for constellations in general?
It's like वो पहले जो internet होता था, dial-up versus the 5G. I think that's the difference
Yeah.
in one line. Yeah.
But do you think we have that kind of capability in-house of putting these terminals on board and having all of these constellations be decently densely packed, so that you drive that kind of how do I say this, end value from even an inter-satellite link and a space-to-ground link with very high throughput?
Yeah.
You don't need, I think, just enough number of satellites in LEO. I think even if you have a much lesser number of satellites density wise, you can start with a relay network. You can start with either the medium Earth orbit, which
Yeah,
Kepler
yeah.
is doing, or you can start with a geostationary satellite. Even one is fine if all you need is over a certain geography. So I think that's still critical, especially for use cases where you need like almost immediate downlinking. So one, while it obviously helps with the amount of data, second, I think it helps with the latency of the data. Eventually, obviously, as you have Starlink, there's so many of them that one of the other satellites is always in the line of sight. But you don't need to get to 10,000 or 5,000. You can start with 6 medium Earth orbit or one
Yeah.
geostationary satellite, too, and that's a
Yeah.
good start.
So every application needs now persistence and real time. You get persistence through a constellation and real time through what you are building. So I think that's where the world will move in general.
But is the downstream kind of demand on the end operator really that real time?
Of course, I mean, if you can provide it at the right unit economics, why not? Every
Yeah.
user would like to, right? I mean, right now demand नहीं है क्योंकि right value पे supply भी नहीं है. अगर
हाँ.
मिलेगा
Shreyaans,
तो क्यों नहीं, right?
what are they, like $1 a GB?
Yes. And see, we can go even lower, but the point is we want to break how the industry views paying by the minute. That has been the game for a large point of time for most satellite operators. They pay by the minute, and we think that as this goes from an endeavor to an economy, data becomes more important. You've seen this happen to your own self from 2G to 6G. You care more about how much is my data than my minute calling, and we see the same thing happen for space.
Yeah. I think we're like in general, humans are very data hungry. The more data you're given,
Yes.
the more data you consume, and that
Yeah.
that
This is why
cycle.
I love orbital data centers. Please send as many orbital data centers that you want.
So let's
Uh,
let's talk
yeah.
about that. In fact, I think that's a very interesting subject to go deeper on. And I'm sure you guys have read this essay from Will Marshall that he's titled "Planetary Intelligence in May." I think there's one point from there that stands out that even 10 years ago, Planet Labs was chatting with Google about, okay, what's it going to take to like do compute in space, right? Like the convergence of sensing and compute in space in a sense. And even 10 years ago, they said when the cost of launch comes down to say, give or take about $200, $300 a kg, it'll start to make sense. What do you guys what do you guys think of this?
Uh,
Yeah, see, I think.
yeah. Go.
Oh, please feel free to go ahead. Go ahead. Go ahead.
Uh, it's interesting because I don't see the $200 to $300 per kg coming down to the satellite operator at any time soon. Elon has done this with Falcon 9. He made rideshare an option, and now the rideshare as an option reduces. So I don't think he's gonna give any one of us those $200 to $300 per kgs. But of course, the unit economics is going to move lower with more launch options being available. So for me, it's just going to be very interesting to see how people plan out orbital data centers, and does the unit economics actually make sense there.
Yeah, I think it was never a technical problem, right? I think, yes, it is a technical challenge, but it is not impossible to put GPUs and compute even quite a few years ago. For example, even the Fireflies that we launched do have edge compute on them, where we have been doing a bunch of interesting experiments. Even before that, there have been a few other places. GPUs are a newer entrant into space, but you could do compute on FPGAs, you could do compute on microcontrollers, etc. It's getting better and better now with GPUs getting stronger and stronger, driven by obviously the unsatiable hunger for all things AI and inference across the globe. I think as I think Shreyan said, just doubling down, it's not a technical problem, it's an economic problem. I think launch cost is just one aspect. So I think what you need to look at is total cost of operations. If you're setting up a ground data center, there's a certain capex to setting it up, and then there's a certain opex to it over the time you're operating it before you. Similarly, for the satellite, there is a capex. You have to build it and launch it and put it up there, and then there is the operational cost of it. Now, the physics basically state that if you're in orbit and you're in a dusk dawn orbit, which is constantly facing the sun, you have unlimited power, right? But the dusk dawn orbit is going to get fairly crowded fairly soon, with SpaceX, I think, taking up all of it with a million satellites or so. And that means that the energy per watt that you're getting is definitely cheaper up there. And as Shreyan's mentioned, the Starship is going to bring down the costs, but there's going to be margins for everyone that's not SpaceX, right? So maybe SpaceX gets $100 per kg, maybe they get to 200. For everyone else, it's still going to be maybe 500,000, 2,000, which is still lower than the $6,000 per kg you are paying today to SpaceX for the Falcon 9. Not enough to, I think, make economic sense. And for it to also make economic sense, you need to have literally thousands of satellites. That's like a bare minimum, because you need to have a certain amount of compute that's kind of up there. Because one satellite is not equivalent to one data center on ground. Like there's like 1,000 satellites that is equivalent to like one big, humongous data center
Yeah.
on ground that's being built. The biggest, I think, impact in the short term will be in the US. If you're trying to build data centers, there's a lot of NIMBYism happening. Don't build in my backyard. It's going to cause water problems. It's going to cause heating, etc. It's going to cause power grid problems. It's probably faster to do it now in orbit for someone like a SpaceX. But over the long term, I think it just comes down to the dollar per watt, but then also dollar per watt per how much time you're able to get it up there.
Wes, in that same essay, Will also talks about how the internet was like the diet for the LLMs that we're using today. Satellite data is going to be the diet for what he calls large Earth models, and then of course he talks more and more about planetary intelligence. So please educate us and our listeners about what Will is saying in that essay and the work you do at Pixxel as well.
Yeah, so my LLMs are large language models, right? I think what world models. I think world models is the new trend
Yeah,
these days.
world
If you
model.
see these company, if you see, I think even Meena Murati's company now, Thinking Machines, they're all focused on world models, which is multimodal data, not just text. I think you have now a kind of reached the limit of what you could do with the internet and the text that's kind of out there. And with satellite data, you have this spatial, temporal snapshot of what the earth has been and what it could be, and then the same technical infrastructure concepts of using large amounts of data to train these models will lead to us being able to interact with this data as well. So I think the interpretability becomes better, but eventually it's only as good as the data that you're getting up there. So it's still the hard problem of, build your hardware, your cameras, your SAR payloads, your satellites, and put it up there. Only as good as that data set is will your inference be as good, but you can make it easier for you to analyze and infer things from there with these new models coming in.
All right. Thank you. Rahul, there's this one recurring theme that kept coming up, but we, for some reason, didn't find the right time to ask the question. The thing with space technologies and space systems is that a lot of them end up being like dual use systems, right? You can use them for civilian applications, but also for offensive military applications. Now, you're in a unique seat to comment on this and help us make sense of this. So please do.
So I think I'll start with one. Offensive and military don't necessarily mean the same. There's
Yeah.
actually, even in terminology, while the US has changed it for themselves, it's still called the Ministry of Defense in India, fundamentally. And the idea, and as even Will talks about in his essay, right? The idea is if you have intelligence to be able to potentially predict what could happen. So one of the biggest mysteries of today is we still don't know how weather patterns emerge or why they behave the way they behave in many ways, which has downstream consequences to everything on this planet in many ways. When I read the essay, what I was most possibly excited by was the idea that can we start figuring out weather better in some way or the other? Because even now we don't have, I think the best predictions are at best 15 days out. We still have no idea about what's going to pan out. And to me, it feels kind of ridiculous if you think about it, that we only know about what the world around us will look like just 15 days ahead of us on something that fundamentally changes how our life on this planet is going to be like for everybody. And I think that's one of those huge open problems. So I'll tie up three things together and then I'll get to the military bit of it,
Sure.
if that's of specific interest. And why I see the military and dual history role. But this idea of planetary intelligence in many ways is what is sort of interlinked with what you call about data centers in space, OSL requirements. The idea is as you have more and more satellites that you're going to put up and get more and more imagery that is available about this, over a period of time, that data will become too overwhelming to start sending down right away. You will actually first have these first set of data centers to just cater to the compute demand on the satellites that they have. And that's the first bit where it will start from. The second part of this, and this is that intelligence that Will in some ways refers to, that we'll be able to know what the world does. About the civilian military fusion, I think we need to sort of go back in history and understand why military has been the sole driver of innovation literally until maybe the last 40 years. And the prime reason for this is you think of allocating resources as a species or as a civilization. And there are two things that you will always spend money on or resources on. One is being able to get more resources, which is food. And the other is defending yourself or fighting to get more resources, which is defense, warfare, whatever you call it. These are the two places where you just spend regardless of what happened, which is the prime reason, if you look at it, the Valley was funded through DARPA money in many ways. Until recently, the largest employer in all of Silicon Valley was actually Lockheed Martin, of all places in the world. NASA Ames used to be a retired Air Force base in many ways. Hewlett Packard started making audio oscilloscopes for the US Navy. And the idea was these were the only people who could fund innovation on any level. And then the world that we know arrived as a consequence of that in many ways. And that's partly what we end up talking about civil and military fusion. I think I don't want to necessarily attribute it to risk capital that has come in over the last 40 years that's allowed for things like these to happen in the private sector. But until 30 years ago, all innovation was literally happening inside these places. Everybody knows enough examples. And again, it just goes back to it's a large pool of capital that can deploy resources over long gestational periods of time and isn't looking at a timeline for its return in many ways. Bell Labs was one of the first private organizations to figure out the same thing. We'll get a bunch of really smart people to come and work in one particular room, and we'll give them years and accountability, but no rush to build something out as such. And in many ways, the military was the first set of metallurgical experiments, science experiments. They financed that, and because you could use that to get more resources. So that's kind of how it works. So I don't think civil military fusion is like a new concept we discovered or we started talking about it. I think the world veered away from it very strongly in the last 30 years, where we thought that we could de-link um, our existence or our survival from um, innovation in some ways.
Yeah. And then there's also the fact that, of course, the world around us today is a lot, less stable than it was until a few years ago, and many countries are now starting to look inwards to develop sovereign capabilities because I think the writing on the wall is no one's coming to save you. So, Rahul, again, talk to us about this idea of sovereignty in the context of technological capabilities. What's important, what can we not afford to get wrong, why is 2047 so important? You call your fund industrial 47, we want to be Viksit by 2047. So talk to us a little bit about all of those things as well.
Lots of reasons for the 47.
Yeah.
You've illustrated on one of those. Yeah, I think the fundamental constraint is energy more than anything else. Like it is true of India in many ways very uniquely. You pump more energy into this economy, you will get a lot more output. We are significantly starved for energy. So if there's like a P1 that I would say, it's just more base load energy requirement in many ways. That was part of what formed the nuclear thesis while we've done fusion, fission with the opening up that's happened in this sector. Uh, and that's just one part of it. I don't think it's going to be necessary. Even that's graded. We've said 100 gigawatts by 2047, but like it, it's about 20 to 25 gigawatts by 32. That's a lot more important. We are at 9 gigawatts today in terms of nuclear capacity that we have available. So I think nuclear is one aspect of it. We're ramping up literally everything, including our grids. So if I have to talk about one thing that's important, it's energy more than anything else. Being able to just produce more of it internally as opposed to importing a large parts of it. So that's P1. I think P2 in many ways is what you'd partly call space intelligence, what you'd partly call jet engines or just propulsion devices in many ways. It's been far too much of a gag problem that we've had. And I just don't mean large level thrusters for just the Tejas program, but even for a multitude of swarm drone programs. If you come up today and the forces decide that, you know what, we need 20,000 supersonic drones, you just can't procure the engines required for it in many ways. And the reason these are critical for sovereignty is there's this very interesting concept it came from nuclear deterrence, where it said if you have one nuclear weapon, it's effectively, or just one way of delivering a nuclear weapon,
Yeah.
nuclear payload, it is effectively an offensive weapon. But the moment you have second strike capacity, it becomes a defensive weapon because that is where it's truly a deterrent in many ways. And that's the fundamental reason why it's called defense, the ability to be able to produce that. And there's a famous quote, you might have heard it as well, given our army background and stuff, where they say, fools study tactics, geniuses study logistics in many ways.
Yeah.
It's the supply chain that gets built out, it's the ability to replenish that gets built out that allows nations to prevail in many ways. So that's sort of part two that, and the reason why I say the way I think of military or space as these sectors that allow us to do that is there is a insane demand that we have for it internally, which is not satisfied domestically today. And all of these industries then result in downstream industries getting built. That for each one of the things that all of these guys on the table need, there are going to be four other smaller SMEs that will get business as a result of it, possibly some that will get built. And I think that's how the industrial base gets built out. You decide that there are going to be 3 or 4 areas. So that's partly the thesis of why, while the fund's called Industrial 47, we focus a fair bit on defense, space, and manufacturing in these areas as such, because this allows for downstream to get built out. And that's why I say, again, critically, energy, think about these larger systems that we need to suffice. Then there's the very standard one that everybody knows about, like the classic baseline semiconductors that we require, the ECUs that we require. And these are all not cutting edge stuff. This is even basic stuff like actuators. We have what 2000, 2500, 2200 odd T72 tanks, all of which work on mechanical actuators. All of them need to be replaced by different types of actuators. So it's this stuff that needs to get built out.
You're
And I
saying
think,
even if we have an indigenous or a platform that's working, there's component dependency which we just can't afford to have. The other thing is when you go out and create, like when you go acquiring platforms, no one's going to let you have the best of anything. So the US will never let you have F-35A. You can have B and C. You'll never get the top variant. And if you hope to have those capabilities, you have no option but to build them, develop them in house.
no, without a doubt, you can have domestic. So localization and offsets is a big thing we talk about in defense. You can have 70% indigenous content and still not be able to fly the plane,
Yeah.
or fly the system, because the critical ones are just not under your control. And we can, and I think we're moving towards a way of diversification in many ways. Where, for example, I think according to the latest 26 CIPRI numbers, our dependence on Russian imports is at about 40% right now. France is 20 odd percent. Israel is about 20 odd percent.
Yeah.
So we're diversifying from just one particular country, but again, we are diversifying into dependence at the end of the day. So the idea is, and that's how it generally works. You have these 3, 4 core technology areas where you will need to build out full stack companies. These full stack companies will be the first ones that will be the progenitors of the next set of companies. So actually, with the Skyroot launch, I was reflecting on it. I think what's going to be maybe even more amazing is there'll possibly be 10 companies that will come out of people who worked at Skyroot now, because they now believe that they can do it and they've pulled it off. And they will just have problem statements for Skyroot that they'll need to solve, each one of which could potentially become a new company 10 years from now. And that's how, in some ways, the technology trickle down works, I guess.
Yeah. I think here we are just talking about the Indian demand, but there's also another, spectrum to it. What about the global south? Countries who also need satellites as a part of their own defense, right? They don't have the NROs. They don't have 6-decade-old space agencies. Who's going to serve them? I think that's another area where Indian products, which are non-ITAR, non-NATO, are will definitely be of huge demand.
All right, gentlemen, because we're also sort of running out of time. I know all of you have something to get to. I think just two closing questions. We can maybe just take them quickly, one after the other. Gaurav, you wrote a post recently, or an essay about just risk and failure and embracing it if you're going to do something meaningful in space anyway. So maybe just share, the thoughts running through your head when you wrote that. And then we'd love all of your thoughts on what Gaurav has to say. And Rahul, also, I think we'd love the investors' perspective on what does it take to underwrite companies that actually have very high risk of failure, right? Like, what odds did Elon give SpaceX when he first started? He's like, there's a 7% chance it's going to work out. And
That's too
some
high.
that is still too high. So, yes. So that's one question. The others, of course, what's next over the next, let's say, call it 3, 5 years for the Indian space economy? And then we'll close this out.
Sure. No, so the essay you were mentioning, I wrote, it was about when will India get its SpaceX. So it was mainly pointing that, even SpaceX had to be bailed out several times by US government and NASA. And they are where they are because of the kind of risk they took. And they were open and transparent about failures. They built stuff, and that's why they are where they are. And for a company to reach there, in India as well, we need to be open to failures. That this is space; it's hard. There will be failures, but it's more about the resilience, staying there till you make it. And I think that is also a challenge to entrepreneurs, that don't make the outcome of the company binary based on one launch. Figure out a way how you can spread risk across talent, finances, projects, because space is hard. A rocket on its day will not succeed, and you can't do anything about it despite your best efforts. So this is something we need to be cognizant about, rather than just expecting successes on every first. And if we are, that will really push India to have a SpaceX.
Yeah, I think the fact that we are even imagining a future like this is crazy. Like, this was not even possible for, and I'll be honest from my side, I'm a byproduct of Skyroot being a launch. I started my journey at ISC because, hey, there's a launch capability at Skyroot, and make a rocket for this. And we see this repeatedly, that for the space tech industry, it is very, again, it is hard, but you don't have to panic. And there's this very, just this quote, that don't panic, is a very core quote from the Hitchhiker's Guide to the Galaxy. The earth blows up, and that's all he has to say. And that's very core to every one of us building here, that things will fail repeatedly, but you just have to be at it and hopefully get through, make it through. Yeah.
I think there's this quote which I think I don't know who said it, but it's like if you risk nothing, then you risk everything. I think that's true more than most for space technology, because if you're not taking a risk, you're not really doing something cutting edge. If you're not doing it, then someone else will come and basically upend you, right? And so you have to consistently be reinventing yourself. But even to start, it's it's a risk, as was mentioned here, right? There's launch. The rocket could blow up. It could be a rocket that has worked like a peach the last 50 times, and then the 51st time it blows up, and it could be your satellite on it, right? Or there could be a solar flare event that's going to be like a EMP, and it'll fry out all the satellites that are launched during that time, and then you can do nothing about it. So I think there's things like that that will be there, but I think what Gaurav said kind of makes sense, right? Risk things and be at the cutting edge, but don't bet the house. Don't take a decision that means that it's all or nothing. You're not playing poker either. But I think that's something that especially investors need to understand a little bit. I think the country has understood, thankfully, that it will take many attempts and many failures. But now, thankfully, there is a tailwind around these investments. It was not the case when I started. I remember, people
Yeah.
used to meet with us because it was interesting that these kids from college are looking at building and launching satellites. Okay, let's meet them. But then when it comes to, hey, you're going to put money into the company, it's like, we'll think about it, right? And that sort of thankfully has changed in the last couple of years. Not least due to what SpaceX has done, but also many other successes that have come out. Rocket Lab, many other companies have gone public. Planet Labs, they've all sort of gave returns to the investors. So now at least investors are looking at it and saying, we'll probably not lose money, as much as we thought we would. And then with AI coming in, all SaaS has become redundant, and so they're looking at where to deploy. And hardware seems like a defensible thing. So thankfully, there's a lot of tailwinds, but they might not remain forever. And the thing that will differentiate real companies from not at that point in time is how dogged you can be and how resilient you can be. SpaceX had to go through those moments. Every company in the space sector has to go through those moments at some point. We almost ran out of money in the second year as well because of COVID when that hit, and our round sort of fell apart. And hopefully, the next 2-3 years will be good, and many companies will get through the valley of death. But once you're out of that, you can hopefully keep on taking more risks and doing more stuff. SpaceX didn't have to do Starlink when they had a fairly profitable launch business, but they decided to go at it. They didn't have to do Starship when Falcon Heavy and Falcon 9 were doing well, but they decided to go at it. So I think we just need to keep taking that as inspiration and moving forward.
Interesting. The investor's perspective on this possibility. Wow. I think, see, just like everybody, my perspective on it has evolved. So when Pixxel was happening, it was there was literally nothing, as you said. It wasn't even necessarily legal that this could happen in many ways. It started from, okay, they want to do it, and there were some very absurd reasons. Awais makes you want to believe. It's one of those things that I've seen about him from them to now in many ways, and Kshitij makes you believe that he can do it. And it was literally fundamentally underwritten on that. There's a whole story I can go into about how I found out about these guys on an Excel sheet line, and initially just began with saying, okay, this is space. Finally, somebody's doing it. And I actually had an aborted attempt with space 2 years prior in 2017 when I almost went to work at Team in this. In fact, one of the things I wanted to mention around policy in India was in 2017, and nobody talks about it as much, there were moratoriums put on collaborating with people outside because it was sensitive national security issues where they were like, you just can't do it. 7 years later, the in-space policy process was mind-bogglingly transparent, where they literally put up and said, okay, these are the things that we're thinking about, tell us about it. The level of stakeholder engagement where they literally went to everybody and asked them. And the reason I know they asked everybody is because they asked me. And I'm fairly lower down on that order, right? So it was insane to see how well, and the founders have talked about how the experience post that has been. I can tell you, like, between 21 and 23, what I saw about their behavior. And it was mind-boggling for me to see that in 4 years we've had this insane U-turn, because I saw the headaches that came in prior to that. So the bet at that point in time was purely founders. By the time it came to PierSight, it was a very clear thesis bet. I would like to believe I was slightly smarter at that point of time. I understood, okay, these are the kind of spectrum, sort of imagery that's going to be available. SAR needs to be made available. Hence, this is going to happen. These guys definitely look like they can do it. They've done a bunch of it here. It was
We
strictly
share
like
a last
a straight
name.
line. Huh? We share
We
his
share a
last
last
name
name.
also.
Yeah.
That also. But I also love the name of their first company, which was just called SAR India. I was
Yeah.
like, these guys have decided we're just going to be straightforward about it.
It
This
was
is
it
what
was
we're
SAR
doing.
Space India. Right, very
Sorry,
clearly.
I missed the space. My bad. In many ways. So that
Still
was a
better
very
than
clear.
Vijay sales.
Pardon?
Still better than Vijay sales.
Vijay Space Sales. And I think so. It's evolved over a period of time where, if I look at the next 5 years of investing, I think of it as closer to a slightly later stage of investing in many ways, where there are sort of two kinds of companies to invest in. One is, can you think of these companies as going and becoming large system integrators themselves, owning a particular end-to-end stack? And the issue there is, there are already a number of companies that have come up in that space. Like, you identify a space and there are at least two people in it, except for one space. And those are one kind of companies, and that, I think, from an investing perspective, is closer to like a Series A, Series B market in many ways, more than a pre-seed or a seed market, which is where we work at. And then second, you have sort of horizontal companies that are betting on the fact that there's going to be a particular technology that's going to be critical across these stages, and that's going to be useful. And that's the likes of, say, a QOSMIC, that's the likes of Eon Space Labs. And there, the way I would underwrite that investment is closer to, okay, one, the base case for the investment flattening out is significantly lower as long as they can solve for the technology risk. And there, the focus is a lot more on, does the team have the requisite technical capabilities to be able to pull it off? Because the demand for the product is very, very clear. And hence, you're just mostly underwriting the technical capabilities of the team to be able to pull it off, with a little bit of sprinkling of, do they have the ambition to build it into at least $100 million outcome, if nothing else? And the reason the second kind of companies today are possible in some ways, and then at least 100 million is the start, and then based on literally founder ambition at that point in time, you either get Honeywell, where you have a suite of products, or they end up going vertically integrated into becoming another potential prime contractor. The other thing that allows these 100 million potential outcomes is companies that got built from 2017-18 onwards. So the Skyroot, Pixxel, Agnikul, Digantra, companies that are now going to become potential acquirers of these smaller companies, also opens up another market for potential exits when you start thinking about it. So I think space that way is at a very mature sector, where we are not like, oh, I like these people, let's swing for it, because there's literally nobody else who's going to do it. And then, just by, I would say, sheer dint of bending the world to their will, these companies end up surviving over periods of time because there's nobody else. To a place where today it's a lot more of a mature market. You can look at exits. There are liquidities and secondaries that are happening for people in multiple companies. All of this has become a possibility. Some of this is fortunately tailwinds of the sector. Some of this is, I think, the adjacencies with just building out manufacturing capability in India, which has applications across not just space, but other areas as well. So I think that's at least how I see the space investment landscape pan out in many ways. And then on the cautious end, there's also the realistic understanding of the fact that, while I agree with Gaurav that there's global South demand, it's a fraction of India's demand in many ways. And we can debate the numbers if we want to. But again, it's the what our demand is to US demand is what the global South demand is to Indian demand
Data mine.
in many ways, if you think about it. There's an order of magnitude difference in each one of those areas. So that collected together can put, and again, that is still phenomenal demand for companies. Like, you make 300 million in revenue across 5 Southeast Asian companies, boom, you're worth anywhere from 2 to 5 billion, depending upon your gross margins that you put in. So that alone is fairly valuable to build a large private company out. But in terms of, hey, is that a market that I get excited about thinking? Not necessarily. That, I think, is the market that gets juiced year 6 onwards. The prime core focus, the way I think about it at least, is the Indian market itself and being able to win there.
Great. Gentlemen, that is the end of our time together for today. Again, thank you so much for giving us an opportunity to understand how you guys think And to our listeners, all I can say is, follow their journeys. They're all on very worthy missions. If you get a chance, join their journeys and certainly root for them while they're on their journeys. Thank you very much.
I'm
Thank
sending
you.
my resume, guys. Okay, cheers. Lovely
Great.
chatting. Thanks for having us, bro.
Yes, I think we've stopped, the recording stopped. Thank you so much. I know we're running a little late.